Hello students, today we are going to talk various types of diode, PN junction diode. Well, let us start talking about a Zener diode. What is Zener diode? It is a specially designed diode which is highly doped and it is reversely biased. So what happens when any diode is reversely biased? We have already discussed that the width of the depletion layer, the barrier layer is wider, made wider due to reverse bias, and if the reverse bias voltage is increased gradually, the depletion layer also, the width of the depletion layer also keeps increasing, and finally a stage may come which is known as breakdown voltage, at which bias voltage the whole P and N type layer will be covered completely by the junction layer, means the whole P side will become negatively charged due to diffusion of electrons from the N side, and the whole N type will become positively charged due to movement of electrons from N side to P side. That means the whole surface P type and N type is overlapped by the barrier, and therefore the PN junction diode starts behaving like a short circuit, because it is reverse bias, so N side is connected to positive terminal of the battery, and therefore the electrons have no hindrance in moving across the junction, and therefore the diode current, reverse bias the diode current is very high, and this current is known as avalanche current, and this voltage at which this happens is known as Zener breakdown voltage. We call it breakdown voltage because if you recall the characteristic of a reversely biased PN junction, you must have noticed that the initial current is very low, but it finally becomes very high at a given particular temperature, which is known as breakdown voltage. So this is usually used to protect some delicate device by not allowing a voltage to get beyond a particular voltage which is safe voltage for the device. The moment the supply voltage becomes greater than the Zener breakdown voltage, the current drawn by the diode becomes very high, so it virtually checks the rise in voltage, and therefore it protects the device from the high voltage given to it. The symbol for Zener diode is just simply modified by giving a Z sign over here to indicate that this is a Zener diode. Now we talk about photovoltaic cell, which is very much in use these days. Whole world is now working for a clean energy, and this is a better source. Of course, it is having some demerit that its efficiency is nearly 25% and around that, so that efficiency is not good. Still, the whole world has no other better option, because it is a silent producer of electricity and also non-polluting type. So that means this is quite dependable, especially in those locations where we have abundance of sunlight. Now how it works, let us see. When light ray is incident, when light ray is incident on the junction of the PN junction diode, then due to absorption of the light incident on it, the electron hole pair is released, and the moment it happens means a electron and hole pair is the bond between electron and hole in the junction portion is broken due to absorption of light energy. It gets excited and goes to higher energy state, and therefore these electron and hole pair are pushed aside under the influence of barrier potential. You see, if you see the direction of electric field due to barrier potential, it is to my left. It is to my left directed. That means the electrons will move to my right and holes will move towards my left, and that means this electron and hole are made available as a free charge carrier at the end surface of the diode. When we connect any load across these two faces of the PN junction diode, this electron is ready to move across the load, and that means power is delivered to the load. Each PN junction diode releases a voltage, creates a voltage potential difference of 0.4 volt. To enable that the light reaches the PN junction, P side of the face of the thickness of the layer is kept very thin so that light can penetrate through it and reach the junction layer, where when absorbed it releases electron and hole pair, and that gives current to the load when connected to the two opposite faces of the diode. This is how photovoltaic cell works. Now, one thing you must be careful that these photovoltaic cells are designed for a given particular incoming light, and usually it is designed for light coming from sun rays, and so it is having a particular band energy gap which will produce the pair of electron and hole in the junction. Now we talk about light emitting diode. This is also very much used in these days because this method of producing light is having very high efficiency. It is very economical. The life of the LED is very high, very long. So this is in use these days. Of course, one demerit it is having that it releases usually one or a few frequencies only, and not the whole range, so that the light becomes comfortable to the human eyes. So somehow we manage it by releasing different colors, using more than one type of LED, using them together so that when they mix together produces a white light effect. Here you see, when we connect the diode with a cell, then electron flows through the junction, and where these electrons recombine with the holes, and as it recombines it goes to the lower energy state, and therefore some equivalent amount of energy is released in the form of photons, and so the light is released. These are few examples that how we can produce infrared, red or yellow color light using these combination of the alloys materials. Now the frequency of light emitted is decided by the energy gap for the given semiconductor used. Now we talk about photosensitive cells. Here you have seen that how we produce electricity when light is incident at the junction of a PN junction diode. Just in a similar way, when light is incident on a reversely biased PN junction diode, then what happens? When the light is incident at the junction, a few hole and electron pairs are generated due to incident light, and the number of hole and pair are created proportional to the light incident, and therefore what is the amount of light incident will decide the conductivity of the photocell, which was otherwise non-conducting. Means it was having not enough number of free electrons which could make it a conductor. But when we allow the light to incident on the junction portion of the PN junction diode, which is reversely biased, then in that case few electron and hole pairs are released, which makes the PN junction diode as a conductor, and the conductivity is more when more is the intensity of incident light falling on the PN junction diode. So that means this type of semiconductor are used for switching on and off a circuit, and also used for burglar alarm, etc. Now we talk about the laser diode. It is a specially designed diode which is LED, which is releasing laser light. What is laser light? You must be aware that a beam of light in which all the photons are in same phase, that beam of light is known as laser light. How it is possible? This type of junction diode is forward biased. When this happens, the forward bias in a forward bias PN junction diode, electron moves through the junction and there it recombines with the hole on reaching the P side. And as it happens, it recombines, it goes to the lower energy state, and therefore large amount of photons are released. This is possible by keeping the doping level high. Now once this happens, the large amount of photons are released. These photons may strike another atom, and these atoms may remain in meta-stable state for some time and may release the photons. All such atoms may release the photons simultaneously, and as this happens, all the photons released are having same phase, and therefore laser light is obtained from the laser diode. That's all for today. Thank you and have a nice day.